I'll turn it over to Jonathan. He's one of our program chairs along with Adam. So Jonathan, I'll turn it over to you and we can get started and hear from our speakers.
Yeah, thanks, Payson. Thanks for the intro. I wanted to give a quick intro as well. Hello, everyone. Thanks for taking the time out of your busy Friday to be here with us this morning. I see a lot of familiar names on the attendees list, which is always a good thing. For those unfamiliar names, my name is Jonathan Garies. I'm a team lead at Sumco Eco Contracting. I've been partaking in this wonderful world of coastal restoration to one extent or another for the better part of about 20 years now, dating back to my high school summers. I've been with Sumco since essentially its inception about 15 years ago. And today I'm actually happy to see a lot of my own project team listening in today. So that's pretty neat. Adam Finkel and I co-chairs. We're co-chairing this event. We hope that there's a couple of key takeaways from today's program. The first being that we're giving a voice to everybody involved, that those on the design, engineering, permitting side of projects have the opportunity to engage and learn from construction professionals, contractors, and hopefully, I guess, knock on wood, with COVID in the rearview mirror, future iterations of this conference will end up being in person. We're able to foster more of a trade show or a marketplace type of feel, where we can engage with each other and potentially match owners with engineers, engineers with contractors, contractors with other contractors, what have you. So there's that. The second thing, we want to convey the importance of an early and open collaboration between engineers, consultants, owners, contractors, whether that be budgeting, feasibility, means and methods, any of that stuff. Because as the old adage goes, what looks good on paper doesn't always translate to sound constructability in the field. So that's what we're hoping people take away from this today. There's a lot of great speakers here, a lot of good talks, I'm sure. And with that said, I'll turn the reins over to Adam.
Thanks, Jonathan. So yeah, just like you mentioned, a lot of familiar faces in the room, and really happy that we can all be getting together despite COVID. So for those of you who don't know me, my name's Adam Finkel. I'm a coastal scientist with the Woods Hole Group. And my focus is on working with our engineering team to design and then permit and help to facilitate the implementation of restoration and coastal resiliency projects throughout New England. And I think one of the reasons that I was particularly interested in getting involved in this particular program was that I come to the table with a fairly unique perspective, having spent the first several years of my career constructing the types of projects that we're going to be learning about today. So having spent that time on the construction side and then on the design, engineering, permitting, and construction monitoring side of things, it's been invaluable to me to have that experience on kind of both sides of the aisle. And I would encourage any younger professionals who are on the call today. Like I mentioned, the construction experience has been invaluable, and I'd encourage you guys to take advantage of those types of opportunities to get out in the field as they become available. So today, we've got a wide spectrum of speakers, and that was one of our goals, was to make sure that we drew on the experience of regulatory officials, contractors, and project owners. To try to provide as broad a spectrum of perspectives as possible. And I hope that we've accomplished that today. So without further ado, I'd like to introduce Rebecca Haney. And Rebecca is the coastal geologist and certified floodplain manager with the Massachusetts Office of Coastal Zone Management. And her responsibilities include research and policy development for coastal hazards, providing technical assistance to coastal communities, other agencies, and to members of the public. And today, Rebecca's talk is going to focus on the range of appropriate nature-based shoreline protection techniques for a geologically diverse shoreline in Massachusetts. Take it away, Rebecca. Thank you.
Thank you, Adam. So thank you for the introduction. My role at CZM, I do have a range of different perspectives and different roles. Although we review some things through MIPA and Chapter 91 and Army Corps, we have a very limited regulatory role. We do provide a lot of technical assistance to local officials looking at projects and trying to assess resource areas, how they function, how proposed projects might affect those functions. We also have a Coastal Resiliency grant program where we fund projects for communities and nonprofits to look at these various shore protection techniques, all the way from conceptual development through design, permitting, construction, monitoring, and maintenance. And so we do have a range of expertise looking at how these things are put together, how the things work in terms of the regulatory review, is also looking at the implementation and seeing what's working and what's having more challenges. So there's a variety of perspectives that I'm bringing to this morning. And we do have quite a diverse range of geologic environments along the Massachusetts coast, which keeps things interesting. Everything is quite different. There's no boring shoreline here. We have quite a range of environments, from glacial bluffs to barrier beaches, dunes. Of course, those glacial bluffs are what's providing the sediment source to create those beaches and dunes. We also have beaches fronting banks, beaches fronting dunes, a range of grain size between those different beaches. The beach in the upper right here is very fine grained, where the beach in the lower left is more of a mixed sediment beach. And then we have more cobble environments and even boulder dune situations that are natural systems. And we need to keep in mind those grain size differences along the coast, and as well as the ledge and bedrock outcrops that we have. So those environments mean that we also have a range of challenges when we're trying to look at shore protection techniques. So the higher bluffs may have a different challenge in terms of exposure. The one on the right here has a very high wave exposure, where the one on the left is more sheltered environment with some fringe marsh. And so each of these environments is very different. Our tide ranges are anywhere from 1 foot to 11 feet. And the sediment types, as I mentioned, varied. And the vegetation, there's quite a range of situations that we're dealing with. So in the altered sites, it can be a little more challenging to pick out the resource areas, but there are still resource areas there. They still have some functions, and it's important to recognize how the system is functioning and how it can be improved. As part of that, we also want to look at sensitive resource areas and make sure we're aware of any nearby submerged aquatic vegetation, rocky intertidal, shorebird nesting, shellfish, salt marsh. These are all going to play a role in the design as well as the permitting and implementation of the projects. And so they're very important to keep in mind. And so with that said, you can't just take one project concept and apply it for shore protection along the entire coast. You really have to look site specifically at what you have at the site, delineate those existing resource areas and the ones in the adjacent areas to the project to see what kind of situation you have, how are those resource areas functioning, what are the values, and those are going to be critical during the design and permitting of the project to understand that, and you want to assess the erosion, the flooding, what is the actual problem you're trying to address, what are all the causes of it, make sure you don't miss the upland runoff. That's something I see that isn't identified in quite a few cases. And so you need to make sure you're addressing all the causes of erosion as part of your project. Also want to look at determining, how to enhance those existing functions. And that's not going to be the same for every site. It's going to be very different depending on which of those situations you're dealing with. It's important to consult with the resource agencies early in the planning to identify any site-specific conditions or resources that might be really critical to your planning so that you don't get too far down in the planning process. It's really tough when we see projects come into MIPA or other regulatory reviews that are at 90% design and they have a flaw because of the something that they failed to address or failed to recognize back in the beginning. So we really like to be able to flag that for you early. I know most of the resource agencies do. It's also important to consider any subsurface conditions at the site, which are going to affect the viability of the project and the constructability. And this has come up in a number of projects that I've seen, and sometimes it affects the actual construction itself, and that causes delays and cost overruns, which you don't want to run into, but it can also affect the performance of the project down the road. So keeping in mind what the site used to be, what some of the subsurface conditions are, that's really important to consider. You also want to talk to contractors about site logistics early to get an idea what might be some of the limitations or challenges with accessing that site. Because if you don't think those through in advance and you get all the way through permitting and start your construction and then realize that you might have to go back, and that also is not going to be very efficient or time sensitive for you as well. So you want to identify the finally the monitoring and maintenance needs of the project, and can the applicant commit to this? In a lot of nature-based shore protection projects, it's very important to have some ongoing monitoring, maintenance, adaptive management program to make sure that it's going to be successful and to maintain it in the long term. And if you don't have a realistic plan for that, it can make the project challenging to implement. So thinking through that in advance is really important. So CZM has developed some Storm Smart Properties fact sheets on a variety of shore protection techniques. Certainly not all of them, but we're working on putting together some more of those. But the idea for these is particularly for property owners to help them make some more informed decisions. And this highlights, what the shore protection technique is, where it's appropriate, where it might not be appropriate, how it functions to reduce storm damage, what are some of the relative benefits, limitations, ways to minimize impacts. We highlight some of the design considerations to maximize effectiveness, highlight some of the permitting, the professional services that they really need to consider. Sometimes property owners think they can do some of these things on their own, and that isn't always successful for certain types of projects. And try to highlight the timeline, maintenance, and really point out some of those issues. So these are resources that a number of different audiences have found useful, and we'll be trying to develop more of those as we go forward. We do try to highlight things like, for example, with Dune Nourishment, trying to make sure you have enough dry beach width to have space for the dune is really important. If you try to over-steepen the dune or put it too close to high tide, then you can have a situation where it erodes much quicker. And so we try to highlight some of these things for different techniques of the things that make a difference in the success of the project. Vegetation is something that doesn't get enough credit for its benefits. We see a lot of places where there's just turf grass and people wonder why they have a little bit of an erosion problem. Turf grass doesn't have a whole lot of root system. It's less than an inch, very little roots, not a lot of holding power. Whereas if you use salt-tolerant native erosion control plants, those can have roots up to 10 feet and can be very helpful in holding the sediment, reducing wave splash, reducing some of the runoff, slowing down the water. And that vegetation can be a very important part of shore protection projects. This example of a park in Winthrop where they just had the lawn coming right up to the edge of the bank. And the lawn wasn't doing much to hold the bank, so they had some erosion, they had some scarping that was going on here. And we looked at this as one of our coastal resiliency grant projects and worked with the town and their consultants to identify what were some ways to enhance this site and reduce the erosion with non-structurally. In this case, they were able to look at creating a vegetative buffer with some native vegetation. They did create some access points through that to make sure people from the park going to the park could still access the beach, of course. And then we saw there was a nice cobble area down here that was protecting the bank quite well, but not so much here. So there was some compatible cobble added at the toe of the bank just to provide that additional buffer. And so it's looking at what you have on site, how the existing area is functioning, what do you have along shore, and trying to mimic that without trying to create something that doesn't really fit. So we do have some tips for installing vegetation. It's specifically in one of the fact sheets, which vegetation to select for which sites, addressing invasive species. We have a lot of tips that are specific to the vegetation that you can take a look at in that fact sheet. You can also add bioengineering to vegetation to be to provide a little bit more toe protection at the toe of a bank. The fiber rolls can be very effective at giving you that toe protection so that the vegetation can take hold. We strongly suggest avoiding Marafi fabric or other filter fabric because that's just going to stop the vegetation from penetrating into the soils and really holding those in place. And the key should be getting the vegetation established, not so much anchoring rolls in place to provide the buffer. Those rolls are your temporary protection while you get the rest established. So runoff, I mentioned, is really important to consider. We've seen a number of sites where runoff is one of the key factors that's causing erosion. Irrigated lawns can be problematic in terms of increasing erosion. Maintaining some kind of vegetative buffer is really important. There's a big difference in how a site like this functions. They have a much more higher erosion rate because of this irrigated lawn, whereas this site has sloped the lawn away from the top of the bank, created a nice vegetative buffer, and they were able to restabilize the bank with vegetation because of their efforts to work on addressing the erosion issues. Fringe marsh enhancement projects are something that we're seeing more of, and these are something that you really need to carefully consider where you're putting them and whether they're appropriate for that site. So you need to think about the potential erosion and flood control benefits to the site, and is that going to achieve what you're trying to do? You want to look at the current and historic resource areas and functions. Did there used to be marsh along this shoreline? Is it something that you want to restore? Or is there marsh along the shoreline that you can look at as a model for trying to establish something here? This is a fringe marsh enhancement project that was done and basically encouraging more of the marsh to grow back in proactively with some natural fiber blankets and the vegetation. You want to be very realistic about the options for your site. You don't want to try to think that the marsh is going to stop 10 feet of surge. Think realistically about it, slowing down the water and stabilizing some of the sediments and have a good idea of what you're trying to do with it. The permitting pathway for marsh enhancement projects and restoration projects is typically easier if you have historic marsh that was there and you're just restoring it, or you're enhancing existing marsh. If you are trying to convert tidal flat to marsh, depending on the functions of that tidal flat, that may have more issues with the fisheries agencies in particular. So the non-structural tows are also preferred for fringe marsh enhancement. So that's something that we suggest you consider as part of your planning process and think about how you can design something that can be stabilized with a non-structural tow. If you're trying to build up a little bit of elevation, you need to think about how you're designing the plantings to stabilize it without long-term tow protection. So if you are building up the elevation a little bit, make sure you're sloping it down and tapering it, and that the vegetation you're planting is going to be able to stabilize that when your temporary tow protection, such as your quar, breaks down. So you want to think about a very detailed implementation, monitoring, and maintenance plan to get these projects installed. That you can look at the adjacent areas and have a good idea what the plants are, but the actual implementation and what plants take where may be slightly different, and there may need to be some adaptive management, so that you may need to rethink which plants you put where. What takes and what doesn't is going to needs to dictate what you can replant and where you replant it. So that's really important, and making sure, as I said, that property owner applicant knows that there's going to be some monitoring and maintenance while this gets established over a period of several years. It's sometimes necessary to do some temporary irrigation, particularly in the upper reaches of a marsh enhancement project, until you get that vegetation established. So keep that in mind as you're doing that. So some resources for your projects. The Storm Smart Properties fact sheets are on our website. You can Google that and come up with those pretty quickly. The Beach Nourishment, Mass DEP's Guide to Best Management Practices for Projects in Massachusetts is available and has a lot of information for nourishment projects. The most up-to-date shoreline change for the state is on our new coastal erosion viewer. That's not linked from our CZM website yet. We're working on that, but if you Google Massachusetts Coastal Erosion Viewer, it comes right up. It has the newest data for 2013 and 2014. And any updated sea level rise projections, the best source for those is resilientmass.org. And Adam, I'm sure you'll let me know if I have a couple minutes left for questions.
Yeah, thank you very much, Rebecca. And I think one of the big takeaways, and I appreciate you circling back on this, but just emphasizing the fact that we do have to have a look at the resource areas, what's existing, the historic conditions of the site, because just because we'd like salt marsh to grow in a particular area, or we think it might be a good idea, or we think it might be beneficial, doesn't necessarily mean that the site conditions are willing to accept that conversion of the resource area. And that's one of the major challenges that we certainly do run into. So thank you for emphasizing that. So we're running right on time. I do have one very brief question, but we got to keep it to about a minute. We did have one question about whether oyster shell bags are a reasonable way to stabilize the toe. And so there was a question about, what about using natural materials such as oyster shell bags, biodegradable ones, to stabilize the toe of fringing marshes, as opposed to fiber rolls or other biodegradable materials?
So the oyster shell bags, the ones that I've seen, they have a plastic mesh, which we have some concerns about, as well as other agencies. And from my understanding is that the potato mesh doesn't last very long. So I'm not sure that there's a good in-between option for those yet. But the plastic mesh is the biggest concern with those. So I think as things develop that are more biodegradable, we can have conversations about those. But this is one of those fields where there's a lot of things still in development, and a lot of conversation to still be had.
Okay. Thank you very much. So our next speaker is Andrew Timmis, and Andrew is the Director of Business Development for the Environmental Group for JF Brennan. An interesting fact about Andrew that I didn't know: he started his career as the youngest full-time town planner in the country, up in Waterboro, Maine, and over the past 30 years has worked for a number of different environmental remediation companies throughout the country. So Andrew's talk today is going to focus on salt marsh restoration in Rhode Island and some of the challenges and lessons learned from those projects.
I appreciate it, Adam. Thank you very much, and Jonathan for including me in the discussion today. I'm just going to go over a couple of projects. The last one was done in 2019, but they were the first salt marsh restoration projects that were done in Rhode Island. They were significant in a number of ways, being the first, but also a lot of lessons learned and a lot of changes made along the way. So I hope today to sort of cover some of those lessons learned, because that's what we really want to do today. So I'll go through some quick facts real quick. What's happening out there, what are we, where are we, how did it start, how was it done, and then more importantly, I'm going to focus more on the lessons learned and so on. Obviously, we're out here because of sea level rise. They're seeing a lot of vegetation die off on these marshes, ponding, algae mats, loss of high marsh species, and a variety of different critical habitat. The impacts are certainly great. They've seen these again and again. Some of these impacts, there's additional flooding on some of these marshes, but some of these impacts are on the community fishing. I'm not going to go through the numbers, but the impacts have been shown and proven out there, the benefits as well as the losses. Tourism trade, obviously, for Rhode Island and fishing are big. And then the environmental benefits, the healthy marshes are filter, nutrient filters, obviously carbon absorption, a variety of other things. And again, getting back to the species of fish, additionally with aquaculture being a key issue on some of these salt marshes, as well as, or the ponds behind some of these salt marshes are critical. And then loss of habitat for species and getting those back. And then even the stagnant pools dealing with mosquitoes and greenhead flies and things of that nature. So where are we? We're in Rhode Island. We're looking at two different areas. The first one is, I'm always tough at pronouncing this one, Quanatahog Pond. If someone wants to correct me, that's fine. I'm going to call it Quani from now on. They're located here. The area that we're going to be dredging is out in here, and there's the breachway access. The other area is Nittigrit Pond. Again, we've got a breachway access, which was part of the dredging application, and then used on those materials for the construction. So the selection process in the previous presentation covered a lot of these, which is true. One of the things that we found is no two sites are the same. So the state went through and evaluated a bunch of these sites, looked at what the species were, what was being impacted as far as the marsh itself, the plant species, the the bird species, a variety of other things. And then through the survey, evaluation did survey of these sites. They actually did cores in a number of locations to determine which may be the best candidates for these first couple projects. And then they came up with two sites. The first one was Nittigrit. Nittigrit was picked for a couple of reasons. One, it had an open permit for eelgrass. It also had funding left over from Sandy funds. And there were some other critical areas that they could gain some financial gain through the towns and being able to contribute to make this project work. So this project basically was dredging the breachway, dredging a channel back into the pond. You can see the sand distribution through here, and then the material will be deposited in various areas across the marsh to enhance elevation and then revitalize some of those areas. The other one was Quani. Again, here was a big dredging of the breachway because it was being, or outside the breachway, it was clogging off the pond, causing a lot of issues with the boat traffic and during low tides. And this area off to the side hadn't been dredged in a long time. So allowing both of these to be dredged as well as Quani or Nittigrit was to allow a lot more water transfer and fresh water going into these ponds. As I mentioned before, aquaculture has become a big issue in those, and the oyster fishermen were really needing to see some additional water turnover. So how it was done, we went out, we did our survey. We used different robotic stations as well as going out and doing hydrographic survey. We determined what the conditions were prior to placement as well as prior to dredging. The areas were tough to work in. We had, for some reason, the two seasons, which were over a year apart, we picked the two coldest seasons ever. The project in Quani, the average temperature was 23 degrees during the entire dredging process, and we had days of wind chills of -40. And you can't stop. Even saltwater freezes at those temperatures, and you can't allow them to deal, get into the dredge equipment and cause any kind of breaking of equipment or anything else. So we toughed it out and worked through these conditions. Obviously, a number of safety concerns involved. So mobilize the site. We had to bring in a dredge, as well as we brought in some amphibious equipment and some barges to be able to move some equipment around. One of the keys is any of these projects is to have a good access point to be able to swing in equipment. Sometimes people look at it and don't think about how it gets done. They just see what they want to get done. So access is a key factor, and understanding what tools the contractors are going to use to make it happen. This was a substantial amount of material to move, so we had to bring in some different equipment. We had to bring in some flexi floats, especially for both projects, because we had to move low ground pressure dozers to across water to get to these different locations. So there was some logistical issues that had to be dealt with. And with that were some of the high flows in those breachways to be able to move that equipment. Never fails when you want to use a crane, it rains, but launching it again, a key component is to understand what you have available for this, because you can see this is a large crane. This is I believe it's a 200-ton overroad crane to be able to lift the dredge and put it into place. So those are considerations that really need to be looked at when you look at when you start evaluating some of these projects. We utilized 2 8-inch dredges on both projects. They're swinging ladder dredges that we had manufactured for our specifications. They're a little bit wider, a little bit higher out of the water, so we can get into very shallow draft areas. Very rarely do we actually get to see our dredge cutter heads work. The water is so clear, we were able to do that in this case, and you can see how the sweeping action of the swinging ladder dredge pulls up the sand, and we can move it to the different locations. The other concern that was presented initially in our first project with CMRC was, the equipment and the effects on the marshes. They were wondering how we're going to get the amphibious hoe over there, and literally when I was talking to Caitlin, she had her back to the water, and I said, "That's how we're doing it." She turned around and saw it basically treading its way across the water with a tether from a boat, because it was the tide was going out, and it would have floated out in the Atlantic if we didn't watch it. But it got over. Then she was concerned with the grass, and these are extremely low ground pressure. This isn't a low ground pressure machine. This is an ultra low pressure. This is a less than a pound per square foot pressure, and you can see it tracked across there. It didn't affect the grass. So it's again some consideration and things to think about. It was determined early on by ourselves that we would bring the low ground pressure dozer over, but we wouldn't put it onto the marsh until we actually had a layer of sand that it could actually work on to help offset some of the ground pressure. So we had a lot of piping involved. They were filling in areas off to different sites, so both dredges would be working into place. And once we got into those places, was then placing the sand. Again, the previous presentation discussed every site is different, and this was certainly true for both of these sites. Ninigret had a very coarse sand. When it was placed, it dewatered very quickly and didn't flow. So we were continually moving the pipes to get to the grades and things that we needed in place. There was some flow, but not as much as the owner had expected. So we were continually moving it to get to those elevations. Some of the thicknesses, it wasn't technically, it was mostly a thin layer placement, which is a big buzzword out there in a lot of the marsh work, but not all of it. There were some areas that they had some severe erosion and significant loss, and they had to bring in some cases, replacing as much as 10 inches or 12 inches of sand to get the grades correct. This was quantity. You can see this material flowed a lot more organic material in this, very fine sand. Was able to move the material quite easily and to get it in place. Once we got it in place, as I said, we had low ground pressure dozers, which is suitable because they're not the ultra low, but it's good enough once you got that layer on top to be able to get the grade. The key was being able to utilize, ground, basically grade control. Grade control was critical on any of these, because these sites needed to be graded in a specific way, not to flow evenly across the sites, up and down through tidal changes, and not create their own erosional effect and channeling. We'll talk a little bit about more of that in a second. So it was very critical in getting the the equipment put into place. I'm going to show you a real quick video, only because it shows some of the activity going on. As you'll see, the project is right on the ocean here. We're coming through the breachway. Actually, that's in some cases, some of that is ice, as it's see-through. This is one of the larger sites, actually it's second largest site at the Quaney site. You can see after it's been placed, it's very flat, a lot of sand, exposed sand, which we'll talk about again in a second. The dredges are dredging in the channel and bringing that material over to those different areas. So getting access and dealing with the tides is one of the critical things as well, understanding what those depths are. And this is the original the first start of the placement on Quaney, covering this large area, filling in some of these different mosquito ditches and moving the material. You can see by the flow, Quaney moved a lot faster than the other. Ninigret was a little different. The material was coarser. You can see it piled up quickly, where we had to then move it and spread it. Both areas, the water was able to flow off quickly off to the side. Very little turbidity, caused a little bit more on Quaney than the other. And you can see this is the area we're pulling the sand out. It was basically filling in almost as fast as we were taking it out. But so once the material was placed, you can see this is one of the large areas. It looks like a barren desert, which for the most part it is, once you put that material down. And you can see in this case, there was some water flowing over and top. And you can see some of the debris line as far as the tides came up. So we had some pretty good grading going through here. Oops, sorry, wrong direction. And again, it was critical to have that equipment up there to get those grades. You can't just sit there and put it out and leave it there in place. It's going to be mounted. You need to get that critical grade across the site. And one of the issues that we kept running into with the grading here was getting and understanding the settlement rates of what these marshes were. These marshes are on top of large peat deposits. So the material needed to be placed and needed to set for a little while before we could actually do a final grade. So we would place it, get a rough estimate as far as what the grade was going to be, where we had to take it, and then getting a first pass, letting it set for a half a day or a day, and then getting back and doing a final grade. Some of the runnel work that was installed afterwards, we did not do this. This was actually done by Save the Bay and Wentley's group. They went in after we were done. They had some predetermined locations. They wanted to have these runnels in place to allow for movement of material up and down the marshes. And they also incorporated some plantings. The plantings were found mainly for a couple of reasons. One, to start regenerating the plant growth, but also for wind control. It wasn't as big an issue on Ninigret, but Quaney was a big issue because of the fine sand. And then we're going back and doing some final survey once it was placed, understanding some of the elevations, doing some plant surveys and monitoring. This was a pre-dredging, post. This is Ninigret, post dredging, and then the final was one season later. So it was well, 2 seasons in a sense. Later, we had some great growth coming in. This is again that site. This was just taken from Tuesday. Dan Goulet got his drone out and took a nice shot of this. As you can see, it came back very well. The runnels are working. The flow is coming across the marsh great. And from what I was told, all the species they wanted are coming back. There isn't any invasive coming in, so very successful. Quaney, this was that large area. You can see some of the runnels that they had installed going through. We removed all of the mosquito areas or ditches. But what they found here, which was brought up before, well, I'll get to that in a second. Again, this is some of the runnel work that was done, some of the growth after one season. And another shot, you can see the growth coming in and the thin layer placement. It's starting to fill in. And the goal here was not to really go back and plant everything they needed. What was to more use what was available and then plant where needed. And this was all natural coming back in. They didn't have to plant this. Again, this was a next season. We got some great growth coming in. Again. and the grasses were coming back fantastic. This was an area that was this is a beach on Quaney by the boat launch. This was just natural plantings 1 season later. You can see the infill is fantastic. Then the first season on Quaney, that spring, they actually had 2 pairs of piping plovers, which they hadn't seen that area in a long time. So that big wide open area of sand attracted them, and from my understanding, they're still there. Second season later. But this is where the keys are that I want to go over. The lessons learned. One of the things we found, again, is was mentioned in the previous, was understanding what the material is, understanding what that material is, how it's going to react on the site, how it's going to be dealt with, and moving it and dewatering it, and getting it across the site. One of the issues that we talked about, and the other is Ninigrit didn't have the issue, but Quaney certainly did. What was found was quickly that there was a lot of material flowing across these areas by wind. This was put in only, this buildup was only done after a day and a half of putting in those fences. And it was an issue that's continuing even now in dealing with those areas. Again, that the putting in those runnels was key. Finding some natural material to help break up the area that also assisted in working with some of the erosion from wind, and also allowing some plant species to gain access. And this is Quaney, so this is the filling in of these large mosquito channels. One of the things that we dealt with there, and I'll talk about that in a second. But the other is they found when they went into here, they didn't really understand all the dynamics in the material. There was a lot of organics in this material we put down on top of the peat. So one of the things they found is it created an anoxic environment. They were getting some plantings going in. They actually went across and did plantings in the site, but they didn't take, as well as the sand that they were putting in, or the runnels they were putting in to help to get those water changes, were filling in almost as fast as they built them. Due to the wind erosion. So again, they're scratched their head a little bit. They've got it sort of figured out now. They're working through it, but it wasn't really discussed or thought of when they did the initial program. The area of dealing with the mosquito trenches, there was an elaborate costing process they wanted to use with different erosion blankets and rocks and everything else. And one of our product managers says, why not use a piece of the sod? And sure enough, everyone's, yeah, why not? And it worked great. Basically, picking up a piece of the sod and dropping it into place, and it worked great for dealing with the initial material moving off the site. Protecting again some of the grass species, but also some of the nesting areas that they had found. So if people use these areas, they're very active. So getting those areas protected were key. This was a very cold day. We had a variety of people in there, the Army Corps, as well as the owner and Save the Bay. Very good discussion, impromptu. We were in 14 people. This was pre-COVID, obviously. A bunch of people in basically a small trailer, having coffee and donuts and just impromptu conversation of how Army Corps is looking at some of these projects. They were very impressed with how the state was doing it and looking at doing some of this themselves. So it was a very good interaction between the groups.
Hey,
the
Andy,
other thing is keep the oystermen happy, get water into their bays, and they will reward you. The boys from Wisconsin that came out, most of them never even saw an oyster, even ate an oyster. Now they all are professional oyster shuckers. They have their own knives and we're enjoying the fruits of their labor per se with the local oystermen in the area.
Hey, Andrew, you got there you go.
I was going to say I'm all set. I just wanted to run
Right
through a lot to cover there. I'm sure there'll be more on questions, but I want to at least cover it pretty quickly. And I guess I'll just wait for the panel to go through anything on that point at this point, Adam.
Sure, we've got some really great questions. Thank you guys for reaching out and getting those entered into the chat. I guess if we do want to just address one quickly, there is a question actually from Jonathan about whether or not you guys were able to determine or able to benchmark a particular rebound rate for the grading of the marsh, that underlying peat.
Well, that's one.
Yeah.
It's a great question, and I'm on a group, as well as Jonathan's boss is on a group looking at thin layer placement with the Army Corps and ERDIC. And that's one of the key components that's being discussed, is understanding what that marsh is. What's the underlying conditions? Are you going to see compaction? Are you going to see these type of issues? Every state's going to be different. They didn't really look at it to begin with, and that's what we're calling it, sort of windage. We're going out there, placing it, having to follow up and look at it. I think with some initial testing and some geotech work, there could be some areas that could be determined, especially for these thicker placements. But that's all part of the preparation and the engineering. And the coastal engineers will have a better say on what those kind of tests would have. But this wasn't done, but that's certainly one of the lessons learned, is really understanding what that was. We saw in some cases as much as settlement of 3 or 4 inches that we had to go back in certain areas to go back and regrade and get it brought up. And especially when you're moving that much equipment around, it gets expensive. So you really want to have it laid out and do it once and not do it 2 or 3 times.
Agreed. Touch it once for sure. And I think we'll hold additional questions to the panel. There's a great one about the permittability of this type of work in the state of Massachusetts. And I think that would be a great question for the panel. So we'll circle back to that. So our next speaker is Jonathan Garis from Sumco Eco Contracting. And as Jonathan mentioned, he's Sumco's ecological restoration team lead, leading Sumco's landscaping, bioengineering, and ecological construction activities. Jonathan supports Sumco's construction team leads, landscaping needs, while also serving direct clients on a diverse array of projects, from native plantings to living shoreline construction. And as he mentioned, his experience is now spanning over 20 years. So without further ado, take it away, Jonathan.
Title of my talk is going to be Teaming Up with Nature. It's basically, I'm just going to go through a few examples of projects that we've done recently, where we've been able to get in on the front end of a project, whether that be in the budget phase, design phase, just conceivability phase of a project. I'm going to go through a few of those, and hopefully, as I mentioned at the top of the talk here, that everybody has something to learn here. It's great to have owners, engineers, contractors all in the same space to really talk things over. There's always something to learn between all of us. So I'll take it from there. As everybody knows, owner, engineer, and contractor, there are a million ways to contract a project. And without getting into the nitty-gritty there, I'll keep it superficial here. The 2 main I want to talk about are basically the private sector / design build, where there's a lot of flexibility that can be had there. With that type of setup, there's a great opportunity for early collaboration, a successful collaboration for a team to go from owner, engineer, contractor right from the start. Make sure all the I's are dotted, T's are crossed. There's a lot of overlap in these industries, so like I mentioned, there's everything. There's a lot of things that we can learn from each other, and building a team from the beginning is one of those steps where a really successful project can be born from that. Public sector bidding is a little bit different. That's what a lot of us contractors are used to. There's a lot of public sector bidding. It's less possible that there's a successful collaboration between engineers, owners, and a contractor with this sort of setup. It still does pay dividends for a contractor at the end of the day. Like it's listed here, there can be timing of the bid or budgetary numbers that can be interchangeable with putting an actual bid together come bid time. So there's some prep work and some before work that can be done that just puts the contractor at a better position once that project does come to bid. If there is a successful owner, engineer, contractor team from the beginning. Like we've been talking about, we feel that there's advantages to that. I've listed here, there's a few advantages. There's some obvious ones and some that aren't so obvious. Developing professional relationships is always a good thing. I think we can all agree on that, right from the owner to the engineer to the contractor and beyond. Good relationships where people know each other, know what to expect is always a good thing. This type of team up builds trust. There's an expectation right from the start where you know what level of work and what level engineering, what level of ownership is going into a project. Smooth sailing from there. Familiarity. Contractors are always working under engineers or in tandem with engineers. So we're very familiar with the engineering that's involved on these projects. Having that overlap between the contractor and the engineer is always a great thing. Not that we check each other on a project, but just being able to have that overlap of knowledge is always a good thing on a project. Another overlooked thing that can sometimes be a good product of this type of team up is a fast tracking of a project where you can kind of get past cumbersome planning and bidding and all sorts of bureaucratic processes that don't necessarily need to happen, but in the public bidding sphere do need to happen. So there's a little bit of a balance there, but sometimes it can eliminate adversarial project conditions. Going into a project as a team where you know each other, you've worked with each other before, you know what the goals of the project are. Everything is worked out ahead of time where you know which person is in charge of what. As long as those things are laid out on the table from the outset, there really shouldn't be any adversarial conditions with a project set up like this. And then, to mention, like I mentioned earlier, with the overlap, this type of setup provides a more complete coverage of design, means and methods, access, budgeting. Everybody's been through that before, and the earlier that you can involve everybody in that process together, it can sometimes pay dividends towards a successful project. So what I wanted to do next is just kind of take everybody through a few examples, much like Andrew just did with his projects there. The first project I wanted to talk about was the Lanes Island Bluff Restoration, which was up in Maine. The owners were the Maine Coastal Heritage Trust. GEI Consultants was the engineer. Yours truly, Sumco, was the contractor. And this was a good example of an early collaboration that went really well. So great title picture here. A couple project pictures on the right there that'll explain, but the teaming up part of this project design intent was to use natural materials. So as much as possible, this project was part of a grant that really stressed using on-site and or natural materials, designing with nature, apparently. And the main point of this project was to stabilize an eroded coastal bank that was on an island in Casco Bay, Maine. Great place to work. If you guys haven't been up in that area doing any work, I highly recommend it. This project here was only accessible by boat and by barge, and that only made the project more fun, in my opinion. So to my first point, using existing and or natural materials, the only imported material that we used for this project was topsoil and some assorted small hardware that we used to lash things together and make the project work. Existing fallen trees were cut to design lengths, as you can see in the lower picture here. And those were fastened together to form a cribbing structure that was to stabilize the eroding bluff. That structure was then backfilled with on-site sand and then capped with our topsoil that we brought on site, seeded, planted native species, erosion control blanket, and buttoned everything up. So this next set of pictures that you see here on the right is more of the construction phase. Top picture is a picture of the bones of the cribbing structure, backfilling, and the bottom picture there is more of a representative of a finished condition. And unfortunately, I wish I had more of an after picture to show everybody in a growing condition after a year of growing, but just being a remote project as it is, we haven't been able to capture a few good green pictures just yet, but hoping to share those in the future. On the collaboration end of things, GEI consultants, their main office in Portland, entered into agreement with us to provide assistance designing and implementing 3 different pilot projects in the Casco Bay and Maine area, using nature-based stabilization techniques. This was one of them. There were 3 different projects, like I mentioned. 2 of them were right along the coast that we could accomplish using volunteer labor and very minimal equipment and donated materials. So those are pretty easy to accomplish. This particular project, Lanes Island, was kind of its own animal. We needed to barge materials and equipment to the site and use construction expertise in order to accomplish what we needed to do here. So we provided, we teamed up with GEI. We provided direction on materials, equipment, means and methods, how we should really go about the project. And ultimately, we were selected as a contractor through the owner. And it was a great project for us. And shout out to Josh Dallasander, who's listening in today, one of my project managers who was the field general on this project. So successful project here. Another good example of an early collaboration, as you can see here, pretty good. This is an after picture, but a great picture nonetheless. At Rose Larissa Park in East Providence, Rhode Island. Owner was Nature Conservancy. City of East Providence had a stake in this. They were great to work with. GZA Geoenvironmental, who I know is represented pretty well today on today's talk. And we were the contractor. So project design intent for this one was really to take advantage of having 2 separate project sites that we could apply 2 different techniques to establish a technique for stabilization based on 2 different ways of doing it. There were 2 different sites. One of them was a hybrid stone bioengineered solution, which you can see in the top photo here. So stone toe with an adjoining coir roll array above that went all the way up to the VE flood zone. So a pretty substantial breadth of a bluff that was restored here. And then the second site, which you see in the being constructed in the bottom photo there, is the stone sill structure and adjoining marsh that was behind that. So 2 different ways of doing it, and it was a lot of monitoring and potential maintenance that were conceived in putting this project together.
John, you have about 5 minutes left.
Oh, gotcha. Yeah, I mean, I'm pretty good. I have a couple more projects I'll breeze right through, but on-site materials for this one, unfortunately, not really suitable. There was a lot of urban fill, concrete, asphalt debris. The stone was variable and pretty small for what we needed. So unfortunately, we had to build it with off-site materials, but results were pretty good. And here you can see these are more of the post-construction photos. Top photos of that bluff restoration, the hybrid stone toe and core log, and down below is the stone sill structure, which you can see off to the left, and the finishing touches on the surface of the marsh there. So collaboration, GZA and Sumco, we were able to team together early on in this project for Nature Conservancy, Rhode Island. I think the project went really well. There's ongoing maintenance and monitoring that's involved here. Early indications are that things are establishing, and actually both of these project types are working out really well. And the third and final project example that I have here is one that we're actually currently wrapping up in the next couple of weeks, but was able to get a couple of good pictures, one of them which you can see here. This is at the Catherine Hepburn estate down in Old Saybrook, Connecticut, which the land is owned by the Lynn Point Land Trust. The project was administered by the Connecticut River Conservancy. GZA Environmental lead designer, and Sumco on the contracting end. We were able to team up and come up with a pretty good design here without taking up too much time. Obviously, top picture, bottom picture are during photos. To the left, you can see the stone sills, the beginning of the marsh construction. Bottom picture there, you can see the finishing touches on the marsh surface again. And again, this was another example of a good early collaboration. It started off as a real design build type of project. The owners eventually actually just kind of went out and received some extra bids for it. But ultimately, at the end of the day, it turned into a pretty good team between GZA and us. And you can see the results here on the right here. I created a list of other early collaboration examples. There's countless of them, Sumco wide. These are a few just related to my team. Just wanted to kind of list a few things to demonstrate some things that we can add on the contracting end during the design and permitting phase. And this is just a nice picture to finish out on. This is at the Hepburn Estate, and this is during construction of the stone sill and living shoreline. And with that, I guess I'll turn it over to questions. Adam.
Yeah, so thank you, Jonathan. I was just on a Teams message with Mitch and Emily, two of my colleagues who are on the call, because we were complimenting the site photos because we've got a couple of active or projects that are in the active design phase, and we just said that they were great illustrations of what we had been proposing for other sites. So one of the questions that came in was whether or what types of plantings were specified for the Lanes Island project, if they were more woody or if they were more coastal salt tolerant grasses and perennial plantings.
Yeah, so that ended up being a pretty good mixture. There was a plant list that was developed early on in the stages, but ultimately what we went with was we basically went and took a biological benchmark, as we call it, and took stock of what was actually growing on the island. Yep. And elevationally just sort of matched that with the breadth of the bluff there. So obviously there was some salt marsh and dune grass species in the lower elevations, with some more woody, shade tolerant woodland type species and shrubs up in the upper elevations.
And that's a good parallel actually to what Rebecca had mentioned about having a look at the site conditions. So that's one thing that we always try to do too, is get out there and have that initial vegetation assessment, and whatever plantings we're proposing, we try to tie into what's existing adjacent to the site.
Yep.
Just one very quick question in 30 seconds or less. So a question that came in about whether you're able to speak about monitoring the effectiveness of the stone sills in either Connecticut or on the project in Rhode Island.
The effectiveness, we have photo and video evidence, and Dan Stapleton, who's going to give a talk on the other end of the break here, he can attest to. We've got lots of photo and video evidence of how effective that is, and especially in a coastal high energy environment like we see with that typical installation of a stone sill. It's been great, and you'll see a stark contrast between what's outside of the sills and what's inside of the sills. And I don't know if Dan's got some of those queued up for his talk, but yeah, we've got tons of evidence. And Julia, yeah, I'd be happy to share some of that with you if you want.
All right. Our next speaker is Dan Stapleton, and Dan's a senior principal and expert in coastal engineering, including coastal processes and shoreline flood protection, using hard, hybrid, and natural and nature-based systems for GZA. And as an expert in coastal resiliency, Dan has extensive experience characterizing coastal hazards, integrating numerical modeling during the design phase, and designing hybrid systems that integrate natural and nature-based systems. And just as a note, we do think that Dan's presentation will be a great segue from some of the points that Jonathan touched on during his presentation. So without further ado, you're on, Dan.
Yeah, hi. It's so far it's been, I gotta say, it's been a great morning of presentations. I've actually learned quite a bit. I'm gonna try and be pretty brief in my 15 minutes here. Just gonna go through just a couple more photos of that Hepburn living shoreline, which Jonathan has already kind of introduced. But most of what I want to do is just go through some talking points about lessons learned from the designer or the engineer's perspective. So this is just an engineering drawing that was part of the bid package for this Hepburn living shoreline. And this project was interesting for a number of reasons. One, it is a pilot project. It was funded by an organization called CIRCA. For those of you who don't know, it's kind of a quasi-governmental organization between the University of Connecticut and Connecticut Deep, which is the environmental agency. So it's a pilot. It was a pilot project for a couple of reasons. One is there have been very few living shorelines designed in Connecticut, so we're really trying to establish the design basis, design criteria. A lot of the guidance for living shorelines came out of the Chesapeake, and we have a much more energetic wave environment in Connecticut. So really just trying to advance the practice in Connecticut, and that's true from not only sort of the engineering and design perspective, but as a pilot project, it had, I think, a lot of collaboration with the regulatory agencies in more of a learning mode than you might see typically on, on a project. The other thing that, as a pilot project, is we did a really a lot of analysis, so a lot of statistical metocean data analysis, a lot of pretty high resolution numerical wave modeling, and that's all in addition to the the typical site characterization stuff. So, and it's wrapping up in construction now, and it's going to go into a monitoring period for at least 5 years coming up after this. So this is the location of the site. It's on Long Island Sound, so it is a pretty energetic wave environment. The project components include these series of 9 sills. They're in a sort of cuspid orientation with overlapping individual sill units. And landward of that, we have the proposed marsh, low marsh vegetation, cobble beach, and then a reconstructed dune. The project also involved a relocation of that tidal channel to move it away from the dune, and that required a new culvert because it connects to a tidal pond. So just some quick photos. That's just during construction. You can see we oriented the sill so pretty much all the work could be done at low tide conditions. So they're working in the water, but it was, for the most part, it was a pretty dry job. And this is just sort of a panorama starting from the one side, looking towards the east, and the Connecticut River, the inlet to the Connecticut River is just beyond. You can see that breakwater in the background. So the job has been substantially complete. There's more dune work. There's some more reconstruction of the cobble beach. And obviously you don't see the marsh vegetation yet. So that's coming up in a few weeks. So really what I wanted to spend most of my, my remaining time is just some of these talking points. And these are kind of my lessons learned, or I wouldn't say lessons learned as much as just kind of points that I wanted to introduce for discussion, within the industry going forward. But the first is that the dynamic nature of these projects really categorically separates them from traditional design and construction. And I start with that point because that sort of sets the paradigm for the entire project. And as these become more common, we have more and more engineers and builders trying to get into this market and starting to get into this market. And I just feel pretty strongly that right from the get-go, these are very different types of projects. And that's true in natural nature-based features in general, but it's in particularly true for when you're dealing in a coastal setting, which is just highly dynamic. Standard of care hasn't been fully established. So, we put these jobs out, we design them. I put my professional engineering certification on them. So I'm very sensitive to having a consistent practice, both from design through construction. And I think that standard of care, while there's great guidance out there, and, I think Rebecca just gave, a really good presentation on sort of regulatory expectations, and they have a lot of guidance documents in Massachusetts. But from the sort of detailed design perspective, there really isn't a fully established standard of care yet. So that's something we're working on, and hope within the community, within the industry. And I think that's going to be something that's needed. Use a multidisciplinary and risk-based approach. So the multidisciplinary part is pretty obvious. We tend to approach these projects with ecologists, landscape architects, civil engineers, coastal engineers. So we have that kind of multidisciplinary team, but I want to extend that to the contractor, because these jobs are almost impossible to do without just a really highly collaborative relationship with the contractor. And I know that's always somewhat contradicted by the owner, engineer, client, or contractor relationships, but these are jobs that just cannot be executed in a traditional approach. The risk-based approach is something that we focus a lot on, but it's really, what I mean there is we evaluate, we do a lot of statistics to evaluate the mid-ocean conditions, the water levels, the waves, the wind, from a probability perspective, and then we look at how the system responds, and we do that right from the design through the monitoring. Regulations may dictate design. New England's got a lot of it's a pretty mature regulatory environment, and the key here, I think, from a designer's perspective, is to really have, I can't say we have a collaborative relationship with the regulators, because that's that's not exactly the way that those relationships are intended to be set up. But what we would like to see is more of sort of a performance-based approach from a regulatory review, rather than just a very specific prescriptive approach. So it's a little challenging as the engineer record, when a lot of the details of the project actually get dictated, solely through regulation. The adaptive management, that's been a big part of permitting for a long time. So I think the key here is that these jobs, no matter how much work you do up front, how much you attempt to do a lot of engineering and design, you're going to see a lot of things happen both during construction and after construction. And you really need to plan for that adaptive management and get as much of that in as you can during the permitting phase, so you don't have to come back and, you know, end up with a change that requires starting the permit process again. But also in fairness to contractors, you know, we want to build enough flexibility in those construction bids to support changes that occur during construction. So on this job, you know, I felt like we had one of the successes, if this job is ultimately successful, is because we had a great working relationship with Sumco, to the point where I would talk to them almost every day. I would get a lot, if we weren't on site, we would get a lot of photographs and videos, and we had to work in the winter. So we had a series of pretty significant storms. And so I did a lot of sort of mid-ocean data analysis on those storms, and then worked with Sumco to see how the system responded. And then we made some adaptive changes during the course of the work. So you really want the construction bids to support that, and you want the permitting to support that right from the get-go. New England, you know, New England has a tough wave environment. And in this particular job, one of the reasons, again, it's a pilot project, is because it faces directly on Long Island Sound, and we want to have a good understanding of really if that's feasible. This is not a job that could be done without these sills. These sills are about 2 to 2.5 foot stone, so they're not exactly breakwaters, and they're not intended to be breakwaters. But this job would not have been, the marsh survivability would not happen without the sills. So it's a tough environment. It's going to require a whole different set of design standards than just relying on some standards that came out of, you know, Delaware or other parts of the Chesapeake. Set owner expectations and limitations relative to the performance and how these things will perform over time. These jobs are starting to get quite costly. They're expensive to build. And, you know, I think you go out and build it, and then a storm comes, and there's been significant impact to it. So we really need to set these expectations and do our best as engineers to and to protect our own, you know, limitations, to protect our own liability going forward. So I think actually liability on the engineering part is going to be something that's really going to have to be faced if we're going to see a common use of these types of features. Design for future maintenance access. So this is something that we did not do on this job, but I will never do another one of these without thinking about it, without trying to include this. So if you can include design elements that would allow, say, a contractor to get back to that, you know, maybe repair some of these sills in the future without significantly disturbing the site or costing a lot of money. And I think we're coming up with a lot of creative ways to do that. So I encourage engineers and designers to think about that. But I'm rethinking the whole monitoring maintenance sort of paradigm. Obviously, monitoring is a given, and the more monitoring, the better. But from a maintenance perspective, I think my current thinking is that we want to, you know, obviously we have to have a certain amount of maintenance to make sure the habitat gets established, vegetation gets established, but I'm leaning more towards letting these sites ride out for 5 or even 10 years, but at least 5 years, without trying to just, you know, bring them back to the original construction condition, post-construction condition, and just see how they respond over time. And in Connecticut, where this job is, there's a, you know, a minimum requirement for 5 years of monitoring and maintenance. So I think the monitoring is a given. In fact, we're trying to really improve how these can be monitored. But the maintenance part, I'm reluctant to have too rigid maintenance requirements in these permits that would require, in particular, the dune here is very vulnerable, that you go rebuild it. I think it's going to be more important to just see how these things reestablish over time and how they evolve over time. So this is my sort of last bullet here. So given all those other talking points 1 through 9, I really feel pretty strongly that we want to kind of rethink the whole contract approach to these. And I'm leaning, you know, trying to think more and more about this idea of having sort of a design, build, monitor, and maintain contract. So Certainly the design build part and the merits of that are pretty obvious, but this idea of extending these contracts through maintenance and, maybe 5-year contracts, maybe even 10-year contracts, I think it's a really interesting concept, but I think it's also going to produce better projects.
Dan,
So
you have about 5
that's what I
minutes
got.
left. Oh,
So I'm done. Yep.
oh, you are? Okay. No problem. All right, I'll kick it back to Adam. You have a few minutes left, that's for sure.
Yeah, so we actually have a couple of great questions, and both of these are kind of coming from the monitoring and maintenance side of things. And this is one item that I was actually interested to hear from you on, and potentially if Jonathan wanted to chime in. But if with all of the numerical modeling you guys have done, have you been able to model or observe any of the potential impacts of salt marsh sills on adjacent properties?
Yeah, so that's
sure.
a really good question. And if my screen is still up, right?
Mhm.
Yeah, so one of the drivers for this project, by the way, which if you can see my cursor running over the screen, is this is a little barrier spit, if you can even it's a kind of generous description of it. And we do know this, we do have some fringe marsh here. So we do know we are, nature is capable of creating marsh here. But this site borders a relatively recently restored sort of high marsh that's owned by a conservation group, the Lynn Point Trust. But this has been eroding at about 2 to 3 feet per year. And it's now the level of erosion is such that it's starting to really encroach on this habitat. And most of that erosion, there's a lot of reasons for that erosion, but a lot of it's due significantly to these structures here, which are causing a lot of transformation of wave action into this area. So one of the goals here was clearly to mitigate that rate of erosion, but to do that in a way that didn't impact these abutting areas on either side. And that's really what the question is about. So on this side, we kind of anchored right here to these existing features. We brought the sills in very deliberate cuspid orientation, but we also brought them inland enough that that had a construction reason I brought up earlier, but it was really about mitigating adverse effects on the abutting property and the abutting area. And it also allowed a lot of the wave activity just due to the bathymetry to break out here. You can kind of see that in this image. This is a pretty strong southerly event. A lot of those waves are breaking out here before they encroach on these. So the toughest part we had right here, we modeled this very closely, and even with the high resolution modeling, there's still a lot of judgment, but we didn't want these sills right here where they terminate to just create, push another problem on down here and start impacting this marsh. So it did come up a lot in our original design, and then that was one of the adaptive management features. We watched it very closely during some pretty aggressive storm events and made some modifications right in here with Sunco on how to deal with that. So it's a tough thing, particularly when you're using hard structures. You don't want to just like push a problem down the road. There is a lot of judgment to it, but I think modeling and detailed metocean data analysis, which is when you talk to like Woods Hole Group and GZA, I think we feel pretty comfortable in that arena, but it's not commonly done even for these types of projects. And but I think you can get a lot out of it.
For sure. Well, thanks, Dan. So our next speaker is Ken Cirillo. And Ken is the director of the Barnstable County Dredge Department, where he oversees the department's 2 hydraulic dredges and their crews. And the county dredge program provides dredging services for the towns on Cape Cod, and it's moving into its 25th year. And just as a side note, for those unfamiliar with the Barnstable County Dredge program, it's a huge asset to Barnstable County and the local municipalities, which gives them the opportunity to leverage the shared asset, and depending on the nature of the project, complete projects well below market rate. In his previous career, Ken had worked for Garmin, so I'll probably have to reach out to him after this and see if he has any connections so I can update to the G3 charts. So
plenty.
we'll turn it over to Ken.
Plenty of connections. Thank you
All
very
right.
much. I think one thing that I'd like to kind of go through here is a bunch of slides just to kind of give everybody an overview of the program before we go into some of the projects. I'm new to the program. I started just in August. I'm not new to the industry, to the maritime world. I'm new to the dredging industry, and I get this great job of kind of being the big cheerleader for our group of guys, and it's a very small group, as you see. So I just want to kind of go through who we are, what we do, and our customers, our stakeholders, and then the overviews of the projects. This is our 25th year, which we started in this last fiscal year. So this is our beginning of our 25th year. The program was started in '96 with one suction, cut ahead suction dredge, the Codfish 1. Then that was added to with the sand shift in '17, and then the Codfish 2 in 2019. So we have two dredges and one that I'll talk about in a second that we converted to a booster station. We've had a handful of pretty significant challenges over the last few years in terms of mechanical breakdowns on the brand new dredges. Of course, the coronavirus also caused a lot of scheduling problems last year, but now we are sort of in a very stabilizing mode this year. We've done a great job. The program, which is very, very unique, it's a county program, and it's set up as an enterprise fund. So we actually have a P&L. You know, we don't take any funds from the county. We are supposed to be self-supporting and being able to have funding to grow the program as necessary. Yet another challenge for us because our rates haven't risen since 2005, 2003, somewhere around there. A whole lot of things have gone up since then. So we are now working on trying to begin the process of getting some better rates in place. The season is quite, unique for us, is that it does start, in the off season on the Cape. Certainly that means October to mid-June. We run into all the time of year restrictions, of course. We certainly wish we were operating in other times of the year, but certainly, as we know, there are many challenges, and not the least one being that you don't want to see, dredge material kind of coming out when you're all sunbathing on the beaches down here. The demand is pretty significant. We do projects for 14 out of the 15 towns on the Cape. The only one we don't do it for is Brewster. Brewster really doesn't have any harbors or channels along the coast. That's the reason why. Most of the programs have funding from the towns. Most of them have 50% or so from Mass Dredge for the projects. The capabilities. This has been a big challenge for us because certainly, as I've seen in a short period of time, a lot of the good old stories of what we used to be able to do and why can't you do it now? And, a big part of the challenge going forward has been to kind of right side the program in terms of what we can do and what we can't do. And I won't go into all these things here, but, it is important because as with any contractor, because we really are a contractor, if you will, you need to understand what we can do and what we can't do. And, previously, some of the problems that have come in is that, where the expectations were unrealistic with what we could do. Some statistics, which I think are great for us, as I mentioned, we're probably about 3/4 of the way through the season. We've kind of coming up at about 102,000 plus cubic yards. We've done projects for 9 towns. Our smallest project was a very small one, but a significant one, 203 cubic yards. We'll go into that one in a bit. And then the largest one was for Dead Neck Sampson Island, phase 3 of a 3-year project, about 44,000 cubic yards. And we just completed a very large project at Stage Harbor, the approach channel. We had up to a little over 2 miles of pipe running from the channel all the way down to a booster station, one booster station, and with discharge further down to the west, Cockle Cove. The dredges that we have, both of these are Ellicott dredges. This is the sand shift, the most recent one. It had a lot of problems. It was a very customized design, which unfortunately ended up being not really appropriate. It had to go back to the factory. Ladders needed to be cut back. Spud lifting system needed to be changed. It really took a hit on the program and credibility. The Codfish 2, another Ellicott dredge, smaller one, capable of just pumping 3,500 feet or so. And this is kind of a neat story, is that this is the Codfish 1, the original one. We were sort of ready to put it out to pasture this past season. But then we decided, well, the hull's in pretty decent shape and the booster pump on board is in pretty decent shape. So let's go ahead and turn it into a booster station. We removed the ladder, we took out all the hydraulics. We've used it on a handful of projects, and it really has helped us out because we've had it in line with 2 booster stations for the Dead Neck project, and it's done a handful of other projects on its own. A very large booster pump, this is a bit 2003, rebuilt this past year, great capacity, and again, needed on these large haul projects. A couple of push boats and skiffs. One thing that we do, which is kind of interesting, is that we do have our own dredge advisory subcommittee. It's made up of all of our stakeholders from each town. These are pretty much the folks that we deal with on a town by town basis. Very helpful right now in terms of trying to get this rate changes going through. The schedule, as I mentioned earlier, it's a big schedule. It's a very, very, very tight schedule with 0 room for problems, which of course are always around us in terms of both the weather and mechanical challenges. We have had one project that we have not been able to complete, is the Bass River project, which unfortunately ran into a toy restriction. A very, very small group doing a lot of work. We have 2 dredge teams, obviously probably floats back and forth. A maintenance engineer that unfortunately he keeps on having to work and not spending the time on doing what we need him to do. Challenges. The schedule, as I mentioned, is just too tight. No allowance for weather, no allowance for breakdown, no allowance for mobilizing. It is something that we have to deal with, trying to figure out some ways on improving on the efficiencies of the mobilizing and demobilizing, having the towns be part of our solutions, storing pipe. We have to haul pipe from way up in Buzzards Bay all the way down to Chatham. We ended up going to the private side on a tugboat, which was absolutely fabulous for us. The toy restrictions are absolutely restrictive for us, especially in cases of winter flounders where we haven't seen and hasn't been reports for 20 plus years. We'll talk about the eDNA project in a second. A big problem we have on the P&L side is in some cases, we have not been able to get out and get the post dredge done in time, and there's significant backfilling, and we're reducing and losing our billable volumes. And probably the biggest scheduling problem is that on almost maybe 70% of our dredge programs this year, we're seeing what was supposed to be the volumes coming from the town, coming from the consulting firm that's working with the town. They're way off compared to reality. And a lot of this has to do with the fact that, until these project sites are resurveyed with more up-to-date technology, we're not going to be able to, have, I think, better efficiencies on the planning side until that's completed. That'll take a while. Mobilization, I think, as we heard, with a few other folks talking about this, it's a big, big, big challenge, grossly underestimated. When you have to go on and bring, 2 miles of pipe onto a site with a booster station and fuel tanks and coolant and pumps and on and on and on. It's not a couple of days. It's a week, it's 10 days, and it's a lot of time. But there's a lot that has to go on, and this is another one of those challenges, in terms of being able to give folks, our stakeholders and everyone else, this is reality. This is not theoretical. This is what happens on the ground, and it takes a lot of time. An eDNA project that is new to Massachusetts, and we are one of the stakeholders and partners on this program. We're looking for some funding right now. They're looking for various funding sources for this. But basically, it's being done. It's being used in a handful of other states where they're going through and with the water sampling on a routine basis, and then they're sending it up to a test lab up in Gloucester, and they're looking for DNA of the winter flounder, specifically in this case. And the hope is that this will give us some relief on a handful of projects, certainly on the south side of the Cape, that we do have restrictions in place blocking us out from being able to dredge because the winter flounder. But again, for the most part, this is a scientific method of trying to see if this will give us the relief. It's unclear yet, but the state, our Massachusetts DMF, are one of the sponsors as well. So it's good to see a, kind of a progressive approach to this. Project overviews, the Dead Neck Sampson Island. I think during our breakout room there, Barry was talking about, he was one of the ones that did the permitting for this, involved with that. Phase 3, it was finished this October, 44,000 cubic yards, about 110, lopped off a big chunk of the island, as you can see here. 3 years, we put different nourishment areas, habitat areas on 3 different places of the island. On the left side is where the island was encroaching on the mainland side. And in 3 years, the county dredge took pretty significant pieces of that real estate away. And flushing was increased, which was one of the major benefits, as well as the various nourishment and habitat generation there. Very successful project. It'll have to be done again. It'll be a few more years, though it'll be much smaller volumes. And we got a lot of work ahead with the town on the west side as well. So it's a very dynamic spot. The center screen just shows the growth of the island over time, and the bottom left shows the phase 1 before it was starting to go through phase 2, on and on. Stage Harbor, this is the project we just completed. Major problem down here. We could have dredged, we could still be dredging, we could probably dredge for another 3 months or more. There's just so much movement coming off from the east, from Morris Flats into the channel. If it doesn't get dredged, the channel will be shut down. We had to widen, we had to open up an area. They are planning to have the Corps come in with a Murden sometime in May, this month, I guess next month. If we didn't do the work, the Murden wouldn't have been able to do that because it's so shallow. Really great shots just to show on the bottom right. This is a very interesting location. There are some significant challenges ahead. It's an annual project. More time has to be spent there. A very difficult environment in terms of the number of weather days that we would have. And the top left just shows, the distance from the top of the center where the channel is all the way down to the bottom where the discharge area is onto a feeder beach, which is most of the project were done that way, deposited in a section where, as the longshore currents would move the sand down the beach to fill it up. We broke the project in 2 parts. We actually did a small job where we filled some habitat for plovers down towards the eastern end, and then the middle section. Little Bay Bourne up in Buzzards Bay, a very interesting project again, improvement, maintenance, dredging, 2 areas. The improvement spot was really a challenge for us. The surveys that were done, does not do the type testing of the bottom. It was very rocky. Major problem, obviously, for a hydraulic dredge where you're supposed to be dredging sand and water, not rocks. A lot of damage could occur. Fortunately, we did not have any, but we did have a lot of times to stop the projects. Again, this was a very interesting one only because the sand, as you see in the bottom left, was moved from a dewatering basin across the parking lot to dry a little bit more. Then it was put in trucks and given to the town of Sandwich for their erosion control on the Town Neck Beach. So very literally a drop in the bucket of sand for a big problem that Sandwich has, but in this case, a cooperative venture between the 2 towns. We just finished this project yesterday, 2 days ago, Pompanesett and Mashpee. Weather challenges more than anything else. Has a lot of exposure from different directions of the wind. Not a whole lot of lees here. 10,000 cubic yards, incredibly shallow. As you can see from this drone shot, left and right of the channel, no water, low water, no tide, no water. So we started and went from shoreline straight out. This was about 10,000 cubic yards, like I mentioned. Interruptions of the plovers. We're past the April 1 deadline. We had to get an extension. We had to get a separate extension. Yesterday, we had a hard stop to get all the pipe off the beach for the plovers. So another time, that we're behind and we're always rushing. On the north side of the Cape, Sassuat Harbor, an interesting one because annual dredging has to be done here. Each of these I'm trying to show that it's the plan was originally 15,000 cubic yards. pre-dredge 9,800. We know we dredged 10,000 easy. The post-dredge came back at just 4,600. This on the port side and the left side of the channel as you're heading out, about a 10-foot high bank of sand that is just sitting there waiting to drop in and fill the channel in, which happened when we had a 3-day nor'easter after we finished dredging. So we know we lost a lot of volume, and we know that that moved right back in and did fill part of the channel. And just different shots. What's the cost of a hazard here? I think this one kind of just boils it down, as a contractor. We have jobs, because we are in this sort of odd position of being a municipality doing work for the towns. We win some and we lose some. And this one we lost. It was a very, very, very small job. Originally, it was supposed to be 3,000 cubic yards. The pre-dredge survey came back and had 233 cubic yards, but there was a shoal that had less than a foot of water at mean low water. Small little harbor, small little area, a lot of boats, recreational boats go in and out of here. A lot of reports of boats running aground, doing the ding, the same old thing. So we had to do it. And we ended up doing it, and 205 cubic yards times $9 a cubic yard. So it was not a money maker for the county, but a very happy town because, again, we did clear the shoal. A day or two to get in and mobilize, probably about 3 hours to dredge, and then another day or two to get out of there. So these are just, some of an example of a job that we could not say, no, we don't want to do it because it's too small. We have to do it, whether it's a very large job, we're going to be camped out there for 10 weeks, or if it's going to be a very small job. And I think that's it. So a very high level and very, very fast. I think I probably used up all my time. I could have gone slower, and I hope after some questions come in, we can spend a little more time, but thank you.
Yeah, that's a great overview, Ken, especially for folks unfamiliar with the program. Just one quick question that I think is actually something that can be answered pretty quickly. So there was just a question about curiosity. Is the enterprise fund funded by a use fee or by a tax to the towns? So who is paying into the fund?
Yeah, no, good question. We have a rate structure. So we have a rate structure, very, very, very simple. If we're using a booster station, the rate would be $13 a cubic yard that the town would pay. And if we are not using a booster station, it's $9 a cubic yard. So for those of you that know what dredging costs in the private sector, we're probably about 70%, under cost compared to private contractor. So the towns are paying that amount. And again, they're either paying in joint venture, like in Mashpee with the private group that's funding the projects, or via the Mass Dredge Fund.
Thank you, Ken.
Thank you.
All right. So keeping things on time and moving right into our final talk before we move on to the moderated discussion. We've got Brenna McGlathry from Duxbury Beach Reservation. And Brenna is the Assistant Director of DBR, the nonprofit organization that owns and maintains 4.5 miles of Duxbury Beach on the South Shore. DBR has extensive ongoing adaptive management and resiliency building projects in the works. And us at Woods Hole Group, we're always excited to partner with Brenna and the DBR team. So I'll turn it over to Brenna.
All right. Well, thanks for having me today. I'm going to speak about some of the nature-based coastal resiliency measures on Duxbury Beach. I'm going to focus more on the process and the partnerships of these projects rather than the technical pieces, because that's not my area of expertise. But first, a brief introduction, just to expand a little bit on what Adam said about Duxbury Beach Reservation and Duxbury Beach. For those who aren't familiar, Duxbury Beach is located on the South Shore of Massachusetts. It's owned and maintained by the reservation, which is a nonprofit organization. So as we know, many coastal areas, including barrier beaches, have undergone extensive development and armoring over the decades, and this can reduce or destroy coastal habitat. Duxbury Beach is unique in that it was saved from that fate just over 100 years ago. In the early 1900s, there were plans to develop Duxbury Beach, to divide it into about 200 housing lots and start building homes. Fortunately, a group of families came together and purchased the property, and that group eventually formed the Duxbury Beach Reservation to continue its mission of preserving the barrier beach in a natural state for coastal protection and public access. So since then, DBR has worked towards 3 primary goals: to protect the barrier beach landform, preserve the natural ecology, and keep it accessible to the public when possible. Coastal protection efforts and erosion control have gone through many phases on Duxbury Beach over the decades, some of which have continued while others have not. Beginning in 1933, when some damaged bridge material was used to construct a fence to act as a sand catcher following a 3-day nor'easter. This idea was finessed a bit in 1962 when sand fencing was attached to the telephone poles that at that point ran down from Duxbury Beach to Gurnett. In 1966, DBR began experimenting with Christmas trees to trap sand. Of course, we no longer do that. Other important measures like planting beach grass and woody shrubs began in the 70s with the help of volunteers. And then in 1991, there was the first large-scale dune renourishment or sacrificial dune implemented on the beach in order to repair the barrier following the 1991 no-name storm. So over the years, the reservation has continued to utilize the experience, field experts, new technology for improving and protecting the beach while retaining its natural character. The reservation has experimented with rows of sand fencing, differing patterns of grass planting, and cobble berms to reinforce the back road and more. This long history of work has helped guide today's efforts in more proactive planning and restoration work to strengthen and increase the resilience of the barrier beach. So one of the recent examples and a bigger project that we've done in recent years is the one I'm going to speak about a bit more today, the Dune Restoration project between the first and second crossovers on Duxbury Beach. Before I get into the actual project, though, it's important to look back a couple of years before construction. The process and the communication leading up to the crossover 1 to 2 project started well before 2018 when construction began. That work was kind of the culmination of several coastal zone management, coastal resiliency grants, and multiple years of work by different groups, beginning with this 2016 Coastal Processes Study and Resiliency Recommendations for Duxbury Beach and Bay report. The report was put together under a CZM grant by the Woods Hole Group with input from DBR. The report looked at historical shoreline change, hydrodynamics, waves and sediment transport, and conceptual resiliency adaptations. So the resiliency recommendations in the report ranged from beach and dune renourishment to salt marsh restoration to moving the channel in the bay. It was really kind of a wish list of different types of projects. One of the major resiliency recommendations was this regional adaptation, which involved beach and dune renourishment along a large portion of the barrier beach. However, knowing that that scale of renourishment would be difficult and pretty unlikely for us from a funding and a material standpoint, the report broke out specific areas where beach and or dune renourishment would be beneficial. One of those smaller projects was dune renourishment between crossovers 1 and 2. So that leads us into the project that I'll talk a little bit more about. So crossovers 1 and 2 are vehicle access points from the back beach road, which is that kind of skinny line of tan that you see back behind the oceanside dune. So those crossovers lead from that back road to the oceanside beach in the oversand driving area. This spot is fairly important part of the beach for several reasons. It's about midway down Duxbury Beach. It has some of the densest nesting activity for 2 protected species, piping plover and least tern. It's an important recreation area. As I said, it is part of our drive-on beach, which is a major draw for the town of Duxbury to actually lease a large portion of the beach from DBR. And that lease payment helps DBR to maintain and restore the barrier. And then of course, the dune in that area protects a vulnerable portion of the back beach road. That road is the only land access and emergency access to the couple hundred homes on the communities of Gurnett and Saquesh, which are located at the southern end of Duxbury Beach in the town of Plymouth. So wave modeling indicated that this area experiences higher wave energy, suggesting higher erosion potential. In stretches between the crossovers, the dune had narrowed to less than 35 feet in width and elevations similar to or just above the roadway. So the project was designed to increase the resiliency of the area. So in the end, the project spanned 3,500 linear feet. The dune was raised to 17 feet and the dune crest was widened to 45 to 55 feet about. 76,000 tons of sand and 70,000 combs of beach grass were installed, as well as 3,600 feet of sand fence. Both of the crossovers at the north and south end of the project were raised to be level with the adjacent dune, and one was re-angled to be a bit more away from the prevailing wind and waves. The project was also designed to adhere to bird nesting habitat requirements with careful communication with the state's Natural Heritage and Endangered Species Program. So dune slopes, planting density, and even sand color were all decided with nesting habitat in mind. So this project, from DBR's point of view, has been very successful. This February, Duxbury Beach experienced overwash in over 10 spots along the barrier beach and had quite a bit of erosion, including between crossover 1 and 2. However, a lot of the width and height of that new dune is still there. The beach grass and the roadway behind it fared fine in the storm. And a lot of the success of this project is owed to the consistency and the communication that took place through the multi-year process. The project was developed and implemented through the course of 3 CZM Coastal Resiliency grants, starting with that coastal processes report before moving on to project design and permitting, and finally the construction piece. So this meant that CZM was aware of the project from the beginning and hopefully had a thorough understanding of DBR's goal in implementing the work, and was part of the discussions throughout the process and could see the kind of follow through from the concept and design phases to actual implementation. And then Woods Hole Group was involved in each of the project steps as well as the consultant, from writing that coastal processes report and doing the analyses to the project design, and then working on multiple pieces during the construction phase. And that again lent a lot of consistency and clarity to the design and the purpose of the project. So strong communication continued throughout construction as well, primarily involving kind of the 4 major players on the construction work. So that was DBR as the landowner, CZM as a regulatory agency and funding through the grant program, Subcommittee Eco Contracting as the contractor, and Woods Hole Group as well. But it also included stakeholders like the communities of Gurnett and Saquesh, any beachgoers coming to Duxbury Beach, as well as the town of Duxbury. So some examples of that communication during the construction phase. Some of it was required by the CZM grant, which that grant was a huge help in funding a large part of the construction. Those communications included public outreach events, monthly progress reports, and periodic team meetings, either on site or over the phone. In addition, DBR hired Woods Hole Group to act as the clerk of the works or construction oversight. One of Adam's tasks in this role was a weekly report to DBR with a summary of what tasks were completed, which areas were finished with sand install and grading, and it had been confirmed with an RTK. These reports were also shared with CZM to keep them abreast of the progress throughout. And in addition, Sumco provided a lot of email updates and phone calls about progress or as questions arose. So all the entities involved communicated fairly constantly, which was a big help to DBR and kind of keeping the public and our other partners abreast of what was going on. It made it easy for us to provide email updates to the public about how the progress was, how the construction was progressing, what the upcoming work was, and any impacts to use of the beach or road, and then reminders about safety near the project site. So a couple of lessons that DBR learned through this project, and this is of course from the landowner perspective. So value experience, as I'm sure many of you would attest to, experienced consultants, experienced contractors, talk to the folks you're thinking of working with and figure out if they've worked in your area on these types of projects, the scale of project that you're looking at, and then take advantage of that knowledge and learn from their past work. Have your ducks in a row. Seems simple, but DBR has a pretty short time frame to do construction work because of nesting birds and other factors. We have between September or November, depending on the project, and March. And then we have to consider any kind of grant timelines for start and end of work limitations. So anything that we can do to have things lined up or done prior to the start of actual construction, whether it be looking at sediment supply sources, updated surveys. We found that got smushed into a pretty short time frame. And for our upcoming next Dune and Beach Nourishment project, we're working with Woods Hole Group to plan for that and get some things done a bit earlier in the process. So communication, as I said, should start early in the project life at conception ideally and continue throughout. And it's important to take into account all the different stakeholders. This seemed to work fairly well for us during this project, including communication with the public. There was some concern, rightly so, from members of the public and the communities at the south end of the beach about access disruptions, but by offering communications early and often, the folks who wanted were aware of what was going on and could plan around that work as they needed to. So something that worked well for DBR during the construction phase was to work and communicate via the project transects or segments that were set up in the design. This was an easy way for everyone on the project team to speak the same language about progress and compare the build back to the plans. And then last, probably an obvious one, be prepared for changes. This is key, especially in a coastal environment. One example, we ran into more sand, ended up being needed at the south end of the project to build it out to spec, either because of changes on the project site between the survey and construction or issues with the survey. So this meant hitting our budgeted sand amount earlier and about 100 feet short of crossover 1. But thanks to good communication from Sumco, DBR was aware of the issue early on and could make a decision internally about the budget. And it gave us a chance to speak to Woods Hole Group about the benefits and overall goal of the project. So in the end, this was a less vulnerable spot and less important to the overall design, so it made sense to cut it short. So this is just an example of 5 of the project transects with the design for renourishment. And that was a really fun part as the landowners, who've been staring at these plans from Woods Hole Group for months to start seeing it translate into reality on the ground. So I'll just go through some photos of that. In the upper left-hand corner, there's a before photo, and then the others show the work being done. Sumco and Woods Hole Group put together a great plan of how to coordinate the timing of the sand trucks and move down the road to different access points for the work. And then in the lower left, we see the second crossover where those vehicles are, where the work started out and then moved north from there. A couple more photos, including the sand fencing that was reinstalled up on the eastern crest of the dune. All the vegetation was planted west of the sand fence to make sure nesting habitat wasn't impacted. In the lower left, we see some of Jonathan's crew planting in the snow. This was another example of being flexible with the deep freeze during a portion of that winter. We had a tough time getting grass right when we wanted it. And then of course it snowed as soon as we did get the grass in. But fortunately, Sumco was ready to jump on it when conditions were right. This was another aspect where communication and the expertise of the contractor was key. And then last on the lower right, we see a portion of the finished project after a growing season. I think that was the next fall. So real quick, to close this out, I wanted to share a bit about where this project has led DBR since that winter of 2018, 2019. So as I mentioned, DBR had a list of resiliency recommendations ready to go from that coastal processes report. However, that would mean restarting kind of a multi-year process between the design and permitting and then construction for each of those projects. So instead, with the support and advice of CZM, DBR began working with Woods Hole Group in fall 2019 on a more comprehensive planning and permitting program for the beach. So basically, we're in the second round for this work through CZM Coastal Resiliency Funding, working through designs and permits for 4 project types. So cobble berms at the Powder Point Bridge abutment and along the bay side where the channel comes close to the barrier, beach and dune renourishment, and roadway maintenance work to address some flooding and stormwater runoff issues. So this project is building off of the 2016 report, as I said, and takes into account a lot of the lessons we learned working through design and construction of the Crossover 1 to 2 project. And the great thing for DBR is once we're finished, we'll stand fairly ready to construct a host of coastal resiliency measures, obviously dependent on funding, sediment availability, and any kind of changing priorities on the beach. So although we're permitting for 3.8 miles of beach and dune renourishment, that is unlikely to ever happen all at once for many reasons. The idea is to work within that larger envelope in smaller segments. So the first project on the docket is dune and beach renourishment at Duxbury Beach Park, which is at the northern end. This was one of the smaller renourishment projects recommended in that 2016 report and is covered under this current large-scale design and permitting work. So currently we've received 1 grant to go towards the work and raise partial funds through a kind of a takeaway event during COVID. So with the expertise of Woods Hole Group and the important support of CZM, we've made good headway on the permitting and hope to have that finished up by this fall or winter and get started on the actual construction. So it's kind of a nice closing of the loop that started years ago with the initial conception of all of those nature-based resiliency projects for the beach. We've gone through a successful implementation and that set us up nicely to kind of dive into a more holistic look at addressing resiliency concerns on Duxbury Beach and starting to actually implement some of that work again. So a thank you to Woods Hole Group, CZM, and Sumco for all of their work in making the Crossover 1 to 2 project a reality, and then their work and support since then. And a thanks to the photographers who helped capture the work on the ground.
Thank you, Brenna. That was a great way to round out the talks this morning. And I think that it was also interesting to hear you kind of touch on the fact that we did try to construct the project in manageable segments between Crossover 1 and Crossover 2. And that was in part because we were constructing the project outside of the time of year restrictions. So we were trying to construct it in the middle of a time of year where we might have a severe coastal storm come in and take a significant bite out of the dune. And so to try to provide some assurances to the contractor and be able to make sure that we had reasonable completion, even if we did have a storm event that took a bite out of the seaward toe, we actually conducted weekly RTK surveys to be able to sign off on reasonable completion for each of those manageable segments. So kind of a different way of monitoring the project, but one that worked out fairly well in this case. Jackson, did you have anything to add, or are we okay to transition into the panel discussion?
Yep, I think it's good time to move into the panel. So I'll just mention, if you have a question, you can start by putting it into the chat. If you want to use the raise hand feature, you can, but I'll let Adam decide how he wants to navigate that. But please don't hold back. Any question is welcome. We got a great list of speakers here, so use the time wisely. And thanks again.
Yeah, thanks, Jackson. So while folks get their questions together and either ping the chat or raise a hand, I do have one question for the panel as kind of a leading question. Just because we have so many consultants on the call today, I guess we're curious to hear from some of the contractors and potentially from Brenna as an owner or Rebecca as a representative from CZM. So if you were in our role as a designer or a consultant or an engineer, I'm curious what you would choose to emphasize during the design phase that we often miss. So I'm just curious to get some feedback from you on that point.
I'll start off real quick. I think one of the biggest things is just constructability, is really looking at it and taking a step back. I mean, you know, we see it, and the other contractors on can say is we see a lot of designs. They're great, they're fantastic, but in some cases they may be built or designed behind the desk, as I like to say, and they don't really go out and really understand what they're asking to do, what equipment may be required, and you know, simple things like access and things along those lines. You know, even a simple constructability review or just bouncing some ideas off a contractor really can help move that forward without having to go backwards once it's found out that maybe that's not the best approach, or some of those questions come up when it's out to bid.
Mm-hmm. Yeah, thank you for chiming in there, Andrew. Any other points from other folks on the panel? Aspects that designers, engineers, consultants often miss that you wish we addressed early on?
I'm the only one with that concern.
All right. So moving on, I think I don't see any hands raised at the moment, and not too many questions coming in. So if you guys do have questions, please feel free to add them to the chat or use the raise hand feature. I did have one additional question. We do have folks from the regulatory side and from the dredging industry on the call today. And I know that there was a question that came up during Andrew's call, or excuse me, Andrew's presentation, and that was pertaining to the permittability and feasibility of thin layer deposition projects in the state of Massachusetts, because they have been piloted in Rhode Island, they've been piloted elsewhere. I know the Army Corps is extensively researching the topic at present, but that was one question that I know came up that wasn't addressed, status of thin layer deposition in the state of Massachusetts.
So Adam, I assume you're sending that one my way.
Sure, if you want to lead off, Rebecca, that'd be great.
So I think, you know, a lot of what is being discussed, and there's a variety of different agencies and interests involved in the discussions, is making sure that the area of salt marsh that folks want to improve needs improving, that there is an existing problem, and that you're not going to cause unintended consequences as part of the project. And so it needs to be carefully thought through in terms of what are the existing characteristics of the marsh. What, you know, I understand some of the ones in Rhode Island were done where there were, you know, large gaps in vegetation. So there's a big difference whether you're doing that in an area that's already impaired or whether you're doing it where you have existing vegetation. So I think it's really important to think about, that some of the same things I talked about of looking at characterizing the existing functions, looking at, what the area, what its characteristics are now, how it's functioning, and is it really impaired, or, monitoring that and making sure you understand how that's evolving over time.
And just a quick follow-up point, Bob Hamilton had chimed in and was just curious with the ongoing research, whether there were any rule of thumb guidelines for sediment thickness that allows established vegetation to come back up through deposited sediments, whether it's through thin layer deposition or through general marsh restoration, and adding sediment to the marsh to try to keep up with sea level rise scenarios. And his follow-up point to that is if there's a minimum thickness that's proving to be constructible in the field. I know that kind of puts you on the spot as far as the state of the practice, but that was an additional question that came in.
Sure. Our wetland scientists are the ones working on those issues in more detail. I'm the coastal geologist for the office, so I'm not really the one that's up to speed on some of the details of any rules of thumb for sediment thickness, but we do have wetland staff that are monitoring those projects and looking at how they're doing, looking at some of the other results. And so what I was trying to communicate was some of the basic things that we're looking for. The constructability part, I agree with Bob's question. The minimum thickness that's constructible is something that we've seen be a challenge as well.
Yeah, Adam, one thing is that's going to be released soon. I think it's in its final thralls of editing and approval. ERDIC, the U.S. Army Corps of Engineers Environmental Research Group, is the department putting together a guidance policy, a guidance document, fairly detailed, very in depth. There's a few people on the call that in their companies have been involved in the review of this. That should be released soon, and I think it'll be a great guidance document for the agencies. Its goal is to be a guidance document for the agencies as a whole, as well as contractors and engineers to look at some of these projects. That should be released soon, and I think once it is, there'll be a big push to get people looking at it, understanding it, and using that as those guidance. They dove into very detailed analysis of just what you're asking about, and pretty much all the different items that we brought up today on any of these marsh restoration jobs, dealing with a placement of and using let's call it a resource, this dredge material, to be able to enhance some of these wetlands and shorelines. The other thing I'll push real quick for ERDIC and Rebecca, it's something maybe your group should look at, is they also have a database they're developing of areas that and locations that need to be dredged because they're looking for those resource materials, and then areas that need to be placed. They may not be permitted yet or not, but it's an easy process to start getting that documentation put together. So there can be some collaboration between people that have a material and need to get rid of it, and someone that needs the material and could use it. It's starting to be populated quite well, and I think it's something that, especially in the Northeast, we have those resources available that need to use it because of the dynamics in some of our locations that have to be dredged, and the environmental conditions that could use that material.
Yeah, absolutely. We strongly encourage the beneficial reuse of dredge material when it's clean, compatible material. And our dredging coordinator is Bob Boeri. He's always taking a look at what's coming through for dredging projects and trying to identify beneficial reuses nearby. I'll often get a question from him about, a certain town is doing a new project. Where are the nearby beaches that might benefit from that? So it's a constant thing that we work on, trying to make sure any of the material we can keep in the system is, when it is clean and compatible, is used nearby.
Mm-hmm. Yeah, thank you for that feedback. One additional question that came in from Dan Stapleton. And again, this is just kind of a follow-up to round out the conversation about marsh adaptation. But Dan was curious and had posed this question to Rebecca. He was curious if any of the SLAM modeling outputs have been used to evaluate salt marsh response to sea level rise and potentially look into areas that could allow for marsh migration?
I know our wetland staff have been involved in the SLAM modeling and they are using that, but I can't speak to the details of how that's being used. It's not my area.
Sure. So I've got an additional follow-up question here from Arlene Wilson, and maybe I'll pose this question to Jonathan, because you guys have constructed several stone sill projects at this point, and albeit I believe that the ones that you featured were in Rhode Island, East Providence, and then down at the Hepburn estate. And this question is somewhat more specific to Massachusetts related projects, with the opinion of CZM and DEP and how they feel about utilizing stone sills. But from your experience, can you talk about how the regulators felt and responded to the proposed stone sills and then the construction of the stone sills at sites that you've worked on recently?
Yeah, it's a great question. Like you mentioned, I think that the two projects recently that we've built with stone sills have been in Rhode Island and Connecticut. So CZM obviously isn't a part of that particular process. I'd actually be interested, as well as you, to know, and I believe Dan and maybe not even Dan, but Steve Lecco in the GZA office would be probably best to answer that question. And maybe even Rebecca Haney would be a good person to ask that question as well. Or Julian Eisel, who's I believe still on the call here.
Yeah, this is Dan. I'll take a shot at it specifically to Connecticut, but I do know the question is directed. It's ultimately going to end up with Rebecca because they're asking about Massachusetts. But in Connecticut, there's a very specific statutory definition of living shorelines, and so it is fairly prescriptive as to what you can and cannot do. I think the challenge with using any hard structure, sills are allowed, but they are hard structure, is, the intention is not to turn these into offshore or nearshore breakwaters. Yeah, that's kind of contrary to the arching goal of a living shoreline. But the other hand is some of these wave climatologies, particularly if you're going to try and do anything on this facing on the sound, are just so energetic that you have to knock that wave down to get any marsh survivability. So, our personal take on it, or professional take on designing these, is to try and be very sensitive to how we design them. Like I said, they're not intended to be breakwaters, and so we spend a lot of time on their shape, their landform, even from a sort of landscape architecture perspective, as well as an ecological perspective. We look really closely at the gaps. We look at how they affect the surrounding habitat, and then try and work with regulators to, from that perspective. But it's putting regulators in a tough spot because, every job sets precedents for another job, and yeah, I'd be interested where Massachusetts is headed. But in Connecticut, it is allowed, but it's allowed, hopefully it's allowed in situations where people respect the overall project goals and not just kind of abusing it.
Yeah, and I appreciate that reply, Dan, and that perspective from elsewhere in New England. I did want to defer to Jonathan and others to give Rebecca a breather there. There actually are a lot of questions on the regulatory side. And I know Rebecca's been involved with CZM's efforts over at Watson Park and Braintree, and there are similar project components there. So I'll turn it over to Rebecca to chime in about the state of the practice in Mass.
Thanks, Adam. So it is important to consider the site specifics. A lot of what Dan said about needing to make sure that you're not going to cause other problems with the project, and making sure it's designed to dissipate that wave energy, not deflect, not design it like a breakwater to deflect, and having a really careful, well thought through project design is part of the part of what you need to be looking at. We've seen a couple projects that have come in with sill components, that we had concerns about the way it was going to affect the other coastal processes, and whether it was going to have adjacent impacts. So each one is very site specific, and it's important to consider, what those impacts might be. So one thing that we are involved in, CZM and the other Northeast states are working together on a NOAA grant on living shorelines, looking at some pilot projects and learning from those. So each of the states has very different things that they're implementing, and we're hoping to learn from those pilot projects so that we can all benefit in moving this ahead. I think it was mentioned that there's not a lot of good, the term that Anders used was state of the practice, or there's not a great resource that you can just point to it and figure out how to do these right for every situation. And so there is a learning curve there. So as they come through, I think there is some concern about what the impacts of those structures might be. It depends on what your tide range and your wave environment are. If you have a 10-foot tide range, you might have to have a pretty big sill with a huge footprint. That's a much bigger concern, is the footprint of the project on the mudflat. So each site is going to be unique and different. And we're looking at those very sites specifically, but you need to think through the same kind of things that I was talking about. There is certainly a preference for non-structural tows where that's possible.
All right. Thanks, Rebecca. I've got a specific question going back to Dan's presentation that we didn't have time to get to. And there was a question for Dan about whether it would be possible to describe the monitoring frequency and metrics as part of this new design, build, monitor, maintain concept that you've developed. And second to that, whether you've received any specific feedback on revising that traditional design build concept.
Yeah, so this Dan, so the monitoring, I think there's two parts to that question. One is the sort of technology monitoring. And this is something that we're very interested in this idea of being able to mount webcams and then using, it seems a little futuristic, but it's actually not that big a deal, but to use webcams and then link that to machine learning algorithms that just actually track a lot of that. So the idea being that we can get sort of very comprehensive monitoring, not just periodic site visits, but we're tracking the sort of metocean data, and we're tracking what's happening on the land. So I think that's sort of the future monitoring. And I know that Circa is putting another grant for monitoring that Hepburn project. I don't know if they'll get that grant or not, but I think that's a concept. Also, I will note that in Rhode Island, both at the regulatory agency and University of Rhode Island, they're using a lot of drone with LiDAR and photography as well in a monitoring perspective. And I know that that's going on in Rhode Island more and more now, at least on a research basis. But the second part of that question is, how do you bring monitoring and what you see in monitoring, how do you bring that back into sort of the design space and the maintenance space? And I think that's sort of a huge part of the future of the success of these, because the maintenance costs, if you have a fairly rigid maintenance program, we've calculated that even on a job like Hepburn, if you want to just maintain exactly what you built, that cost over about 5 years is probably going to exceed your initial cost of construction. So, that's just not going to be sustainable, financially sustainable. So I think, there's a lot of thinking that needs to happen on how these systems evolve and how you really develop a maintenance program that looks at that. And then how do you take the monitoring to inform that maintenance program going forward, rather than a sort of more traditional is like, this is what we built. If you got to go out and look at it so many times and after storms. And if you get like 25% of marsh loss, you got to go back and replace it. I think, that is the monitoring program we wrote for Hepburn, but I think now going forward, I think we're going to see a lot of more sophistication in those monitoring maintenance programs. I know it's a great
All right.
question because there's a lot of potential opportunity to work on this kind of stuff going forward. So
Yeah, that could be its own segment. So
That's another component of the Northeast project that we're working on, is the monitoring and maintenance protocols, and working together with the other states to try to come up with some more guidance on that.
All right. Well, not seeing any additional questions coming in, so I think we'll look to wrap it up there.
Adam, I
but
did
I-
have a hand up. I guess you can't see it.
Oh, all right. We've got one more from Andrew. Let's hear it.
I figured everyone's been left out. I'm going to ask Brenna a question. And well, first, I pay my fee for the drive-on beach every year, and it's a great environment. If anybody's had a chance to get on Duxbury Beach, especially the drive-on side, it's fantastic. And I have to compliment both Sumco and them for the work that's been done down there. It's been fantastic. But as sort of I guess an owner of a beach or the resource, as the construction goes forward, how do you balance the construction, and how are you going to balance the access to the beach? Because the people that are funding a lot of this work are actual beachgoers and things like that as well. So there's sort of a vested interest as an owner to support your clients, at the same time get the projects done.
Yeah, so in that sense, the plovers really help us out because the time of year restrictions for work, we're doing the work during the winter time typically, which is not when as many folks are out there. We do have a third access crossover if, in that project, if crossover 1 and 2 had to be closed, but we have multiple access points. There's oversand areas beyond that area. So it wasn't a problem that winter, but those seasonal restrictions do help because we wouldn't be doing work during the spring and summer and early fall. Weather is nicest and folks want to get out there. Then the plovers have their own say about recreational access, of course, during that time of year. But as far as the construction, they kind of help limit any work. And then as far as the projects themselves, the components that we're looking at, I think will probably be beneficial to recreationalists in the long run. The biggest portion, the biggest project component is the beach and dune renourishment, which Duxbury Beach is not getting a ton of new sediment supply because of the armoring just to the north of our property line. So our opportunity is to bring in sand, and that's what's going to keep those pedestrian beaches and the drive-on beach in existence, and concentrating on kind of the northern area as the sediment moves north to south there. And then a lot of the work is on the access road, which again won't inhibit access at all, or on the bay side where there's existing kind of cobble areas. So again, won't reduce recreational area.
And the snowy owls aren't a factor in the winter?
No, not so far.
No, they just monitored the site, kept an eye on things when we were out there.
They're cool to see. I mean, they're so cool to see when you get out there and see them.
Yeah, they are our popular visitors in the winter.
All right. So I think I'd like to certainly thank all of our speakers. I think that we covered a lot of ground today and heard from a very wide range of perspectives. And I hope that was useful to the program participants. So thank you very much again to everyone who participated as a speaker today. Really appreciate it. And I'll turn it over to Payson for closing remarks.
Great, thanks, Adam. Yeah, I want to echo that and thank all our speakers today and our attendees as well. At one point, I think the participants number was well into the 30s, and we're still at 30 now at noon. So it's a good credit to the program. And Adam and Jonathan, I want to thank you as well for pulling together a great program. And just a reminder, there's the webinar feedback. Hopefully you've given us some feedback. We do use that as we do our program planning during the year. And Jackson will get the video recording posted here over the next few days. And we hope you get involved with our group. And then lastly, just a reminder, on May 13th, we have our next program about the CAD cells. So I want to thank everybody for attending today. Hope everybody stays well, and we'll see you on our next program.